Hi, my name is Lisa Soule, and today we're going to talk about submaximal testing for your clients. Today we will cover the 1 mile jog for individuals 18 to 29-year-olds and the 1 mile walk for individuals 20 to 69-year-olds. For the submaximal test today, the equipment we will be needing is a paper, a pencil, a stopwatch, a track or a flat surface, and a scale. The scale will be used to take your client's weight. Remember, when you take their weight, that you need to have it calculated in kilograms. Now I'm going to talk about the procedures for the jog and the walk. For the jog, remember that it is for 18 to 29-year-olds. This is not a maximal test, it is a submaximal test, and the reason for this is because we want to reduce the risk of injury. For this test, you want your client to jog at a comfortable pace. For males, you do not want them to complete this jog in less than 9 minutes, and for females, you do not want them to complete it in less than 8 minutes. Anything over that is fine. After we do the jog, you are going to record your client's time, and you're going to record their post-exercise heart rate, and I will demonstrate later how to do this. For the walk, the 1 mile walk, remember that it is for individuals that are 20 to 69 years old, and you want them to walk as fast as they can. You do not want them to jog, and you do not want them to run. When they finish, you will record their time, and then you will also record their post-exercise heart rate. Okay, and one more thing before we get the test started, I'm going to show you how to take heart rate. There are 2 ways of taking heart rate. You can either take it through your radial artery, or you can take it through your carotid artery. First, I'm going to show you the radial artery. What you're going to do is you're going to take 2 fingers and you're going to place it on the thumb side of your arm on the radial artery. You're going to hold it there and you're going to count the beats per minute for 15 seconds. You can use a stopwatch or a regular watch to count the 15 seconds. Once you get to the 15th second, then you're going to take that number and you're going to multiply it times 4, and that'll give you your beats per minute. For the carotid artery, you're going to take your 2 fingers and you're going to place it right on the carotid artery. You're going to be able to feel the heartbeat, and then you're going to count that for 15 seconds using a watch or a stopwatch, and after the 15th second, you're going to take that number and multiply it times 4. Your clients get ready to jog and walk, you want them to warm up. For the joggers, you want about a 2 to 3 minute warm-up, and in this warm-up, you want them to warm up their muscles so you can have them take a quick lap around the track. For the walkers, their warm-up should be between 5 and 10 minutes, and for them you want them to do some static stretching or some dynamic stretching just to get those muscles warm so that they don't get injured. Okay, so here are 2 clients. I have Shauna and David. Shauna is 20 years old, so she falls into the jogging category, and David is 30 years old, so he falls into the walking category. So now I'm going to have them get ready. Okay, ready guys? Go. Time. As your client is running in, you want to make sure that when they finish that they run past you, and that's when you take their time. Now I'm going to take her post-exercise heart rate. Okay, so remember, you have to place 2 fingers on the radial artery, and you want to take it for 15 seconds. Once you get that mark, you're going to take that number and multiply it times 4, and that will be her post-exercise heart rate. And time. Again, you take their time right as they pass you, and then you take their heart rate. When you take the heart rate on the carotid artery, you want to make sure that you don't take the heart rate both sides at the same time. You take it for 15 seconds, and when the 15-second mark hits, you take that number and you multiply it times 4. You're going to go over VO2 max. VO2 max is the maximum amount of oxygen that our bodies can consume. Now let's go over the 1 mile jog equation for VO2 max. Once your client has completed their jog, you are going to need to use their body weight in kilograms. So you will need to convert their weight in pounds to kilograms. And to do this, you will just divide their body weight in pounds by 2.2. You will need to use their time that it took them to complete the jog. You will need to convert this time in minutes. And in a little while, I will show you how to do this. You will need to use their post-exercise heart rate and their gender. For their gender, you will use a 1 for males and a 0 for females. Converting from seconds to minutes, you need to know that 1 second equals 0.166 minutes. So for this example, my client jogged for 10 minutes and 17 seconds. You will multiply 17 times 0.1667, which will give you a total of 2.83. Since this does not complete an entire minute, you will write it as 10.28 minutes. And this is how you convert seconds to minutes. Here are 2 examples of how to calculate VO2 max for the 1 mile jog. In example 1, I have used a body weight of 68 kilograms, which is about 150 pounds, a time of 10.28 minutes, which is 10 minutes and 17 seconds. For this example, our client is female, so we will use a 0, and her heart rate was 124 beats per minute when she finished her jog. So I plugged in the weight, the time, the heart rate, and her gender. Now, when you go in and you will first multiply and then you will subtract everything at the end and get a total of 50.042 milliliters per kilogram per minute. So that is the VO2 max for this first example for our female client. For example 2, our client has a body weight of 90 kilograms, which is equivalent to 200 pounds. Their time was 12.3 minutes, which is equal to 12 minutes and 2 seconds. This is a male client, so we will be using a number 1, and his heart rate was 155 beats per minute post-exercise. So you will come in and include the body weight, the time, the heart rate, and the gender. You will multiply, subtract, and add for this equation, and we got a total of 46.4 milliliters per kilogram per minute for this second example. Again, you just go ahead and plug in the body weight, time, heart rate, and gender. Make sure that you use the correct units when doing these equations. Now let's take a look at the 1 mile walk equation. To find VO2 max for your client for the 1 mile walk, you will use this equation. For this equation, you will need your client's body weight, but this time you will use pounds. You will need their age in years, their gender, their time in minutes, and their heart rate post-exercise. Again, you need to convert seconds to minutes, and by doing this, you will multiply your seconds times 0.1667. For gender, males, you will put a 1, and females, you will put a 0. And don't forget, body weight for this equation is calculated using pounds. Here we have an example for calculating the 1 mile walk. In this first example, our client has a body weight of 160 pounds. Their age is 30 years old. They are a female, so we will be using a 0 in this place where gender goes. Their time was 13.5 minutes, which is 13 minutes and 30 seconds, and her heart rate was 135 beats per minute. You will plug in the 160 pounds, 30 years, a 0 for female, 13.5 minutes for time, and 135 beats per minute for their heart rate. You will then subtract everything out, and you will get a total of 43.714 milliliters per kilogram per minute for her VO2 max. In this second example, our client is male, so we will be using a 1. Their body weight is 240 pounds. Their age is 47 years old. Their time was 12.96 minutes, which is equivalent to 12 minutes and 58 seconds. Their heart rate post-exercise was 140 beats per minute. So just like the other equations, you will go ahead and plug in their body weight in pounds, their age in years, a 1 in this case since it is male for gender, the time, 12.96 minutes, and his post-exercise heart rate. You will go ahead, subtract. In this equation, you will need to add and then finish subtracting out, and you will get a total of 38.26 milliliters per kilogram per minute for their VO2 max. Make sure that when you are calculating VO2 max, you keep the units milliliters per kilogram per minute.